I want to tell you how you can find your own evidence to confidently know that the earth is not flat and curved. So, in order to do this, we need to start completely over at a blank slate. You know nothing about anything about the shape of the earth, and we're going to start from square one. And what we're going to start is going to be in the middle of the ocean, and you're going to be on an island, a long, skinny island that's going to be really, really long, but it's skinny, okay? And this is the first time you're going to wake up, you're going to open your eyes to see what the shape of the earth is. And you're going to look out and you're going to see a straight line in the horizon with the ocean. You're going to just completely look around and you're going to think, wow, I'm either on something that's flat or it is possible that I'm on something that's curved, but it's really, really big. I don't really know. So what can we do? Remember, we're on an island that's really long. So you could see the sun and you see that it's sort of rising up from the horizon. So you can think that either the sun is rotating around the earth, or the earth is rotating because it's going from top to bottom. Any other reason why that is not the truth would need some explaining to do because of what you're seeing. And so you're seeing the sun go up, and let's say you want to do some get some further evidence. So you're going to walk along this island, and you're going to go all the way down right to where the sun was. And it's a straight line. It's a straight island. It's perfectly straight, and it goes right to where you saw the sun rising in the sky. And you're gonna go all the way. Say that there was a say that there was a mountain in that range where the sun was, and the mountain was, you could say, 1,000 feet. Yeah, okay. And you reach the mountain, and that's where you see the sun disappear. Right, that's where it's been disappearing near this mountain. The mountain isn't blocking the sun, and so and you don't see the edge of the earth, and you're like, okay, so this must be a really big object, and I don't know if this is flat yet or curved. You don't know if, just based on your traveling, okay, going to where you saw the sun setting. Now, when you want to start thinking about what the sun does, and that is the top reason, because the sun sinks, you can already visually understand that the earth is curved because the way that it goes up, and then you just investigated the part right there. I think I'm saying this. All right, I'm not getting tripped up on what I'm saying about, you're going to see the earth being flat and you need to do some more evidence, but I know that just visually you're supposed to be able to know that the earth is curved, just, and you don't even have to go out and do that exploration. Or I might have had this on the other video where I said you don't know. So yeah, at that point, when you see the sun rise, at that point you don't know if the earth is, well, once you, oh yeah, that's what it was. So once you find out that the sun, that you're actually revolving around the sun, then that means that the earth has to be rotating, okay? But oh, that's why. Yes. So you do not need to go out and actually physically go to see where the sun disappears over the horizon to measure if it's flat or not. That's just further confirmation. You already know that, because if it was rising up from the horizon like it does, right? It shows from the top to the bottom. You see the top of the sun, right? It's a little curve. It's going to be like a little, like, bit of a curve. I don't know. And that's the top of the sun. And if you can see the sun, then other people should be able to see the sun. The whole world should be able to see the sun if it's flat. So, oh yeah, so you would need further evidence. You would have to go to different areas to see if they also had the sun. So I guess at that moment in time, with no other information, you technically don't know. If you don't move, you don't know what the shape of the earth is, because you don't know what the size of the earth is. It looks flat, or it could be curved and be really big. You don't know this at this moment. So yes, you would need more information. If you were just there, remember we started at blank, at square one. We don't know anything about any information. So at this point, you do not know. The sun could be smaller and closer away and closer, or it could be bigger and farther away. Like there needs to be more data. So that data is just not complete unless you can figure out some other ways where the through, I think it's deductive reasoning, that you can find some other information out, and through process of deductive reasoning you can determine maybe that the earth was curved or flat. So that would be really interesting if someone had a proof like that from the position where we're at right now. We're at an island, we're seeing the sun rise. So we still need more evidence, and it looks like. And so the evidence is, you go to where the sun appears from the horizon, and because you did not see the edge of the earth, you know that you are on a round surface because water levels out, right? It's smooth. Um, Water is going to have a smooth area on top of a surface. So hmm. It's not like the Earth's gravity just was like a magnet and it attracted like the water and it just started shooting up into space and it was just attracting like that. I guess it doesn't do that. It's too heavy, I guess, or won't have that kind of like a magnetic effect. Like, magnets would like stick up and they'll hold like a rigid form. Um, it's not like a magnet, so it's a less intense. So gravity's less. So anyway, because it's a circle, right? And then water would just like pour over a circle, it always go down to gravity. But because it's the Earth and it has enough mass and gravity, it acts like not a stickiness, but an attraction, and so it's pulling the water on the Earth perfectly. It would be perfectly level if you had enough water to enclose all of Earth. It would be perfectly level. If Earth was a perfect smoothness as well. We will change it, right? Earth isn't perfectly smooth, but it's very close to smooth. And so the water was around it, yeah, perfectly level. Okay, so that's another assumption that, well, it's not an assumption, but and remember, oh yeah, so that, and then the water would be a very calm day, like it would be very smooth. So I just wanted to, I guess that was an assumption, but we also kind of, yeah, we would have to get more evidence to know how water behaves, and that's how we can say, well, it's either a flat or a curved surface. It would depend on what the shape of the yeah, it would depend on what the shape of the Earth is. But yeah, okay. So all right, I think I explained that point well enough. So we're at 8 minutes. So, good amount of information in this video. And so once you go to the mountain and you see that the sun is not there, or the edge is not there, you know that you're on a round surface. That is the number one reason why you know that you are not on a flat surface. Because when you are, if you put like a cereal box on like a 5 foot stool and then you go on a flat surface and you walk away from it like 100 feet away, and you're just looking at the cereal box as you're going away, it's going to get smaller and smaller and smaller. That's what happens. It takes up less of your field of vision. And it does not disappear from the top to the bottom. When something's going over a curve, like say a hill or something, you're gonna see something disappear from the bottom to the top when it's going away from you. So that is just the fundamentals. So we could do that. We know that how that works on the island, right? We were able to take that little bit of information as well, that things get smaller when they get farther away. So you know that the sun is not above the horizon and it's coming into a field of view. It's coming from around a surface. It doesn't necessarily mean that it's a round surface. It could be an edgy surface, a flat surface. But it certainly is going around it, and because of the way that the sun comes into effect. And that is literally all the information and you can do this research because you know what the sun looks like, and hopefully you're in an area that you can see the over the water, and that's a good way to see this. And you need no more information than just that. Don't go to other reasons if they ask other questions unrelated. Literally just stick to this one topic right here, the observation of the sun rising over the horizon and being able to travel. Because so in theory, if you try, let's say you go farther than the mountain. Let's say you continue following the same path that this island, right? This hypothetical island that's skinny and long. Let's just say it keeps going all the way around the earth, or because you don't have a boat, but let's just say you have a boat, right? Because that's more realistic. And okay, you have a boat or a plane, but let's just say a boat. You can just literally keep traveling. Well, eventually you're going to hit land. Let's say you go east to west. But you could maybe go on a car at that time. But anyway, so you could just keep traveling. So that's one way to do it. You could just keep traveling, and then if you never saw an edge and you ended up in the same spot because you were going straight, remember, which you can do that. You can go east to west. You can circumnavigate the earth. Well, you could do north to south too, but be a little bit easier going east to west, and it happens every day, right? So you could go east to west. If you never see an edge, then guess what? The earth is round. And and all you need to know is the properties of water on a sphere, and then you would know that it would behave like a sphere, and water would be smooth, right? It would want to level out equally, and that would be it. You would know what the shape of the earth is based on traveling, and then you could also get higher up in the sky, because once you go to the sun, right, where the mountain was, remember, it was far off in the range, 1,000 feet high. Maybe the mountain was 10,000 feet high. That'd be really far away, but whatever, 5,000. I guess that's not too far away, right? 10,000. Oh, let's say the mountain, I don't know. I wasn't giving a distance about how far away it is. We would know how far away it is based on Earth's curvature. So I'm wondering how big a good mountain is. If maybe like 3,000 feet or something, or 5,000 feet would be a good distance. But once we go to that mountain, right? Let's say another example. Say there's two mountains. The other mountain is 1,000 miles away, right? We wouldn't be able to see that unless the mountain was so high with the curvature. But anyway, the point is all right. Let's just say that okay. Let's just say that mountain was like 20 miles away, or 50 miles away, 20 to 50, and let's make them up my mind. Let's say 40. And there was more mountains every 40 miles, okay? And yeah, I'm scratching my head over here and making it all poofy. So you keep following the sun. You keep going every 40 miles. And you're going to figure out, like, hey, the earth is really big. So now when you shoot up like a balloon or a rocket, like, you might have to go up really high before you can start seeing just the edge of the earth, like looking at just the, not looking directly down at it to see what it looks like. You might have to just look at it as an angle, because Earth is going to be so big that you're just going to be able to see the curve of it. So now, but that is possible. You can take something up and get a picture of the Earth. This is not something nowadays very complicated. We have the technology to get things very high up and to take pictures, transmit that data, or we can collect the camera. But we do have the technology nowadays. It's not hard to travel the world. It is possible. It's very possible, plane or by boat. So you should be very aware and alert right now. Like, when this is something that's so easily accessible to prove, why is it even being debated? So that should be a big red flag right there, because it's very possible. And from my research, that there isn't even a flat Earth model. They don't even have a consensus, a model that actually makes sense, that can predict exactly what we see in the sky, in the sky, like the stars, where the sun is, where the moon is, when daytime, nighttime is, like how does. There's lots of, they don't have things worked out. And that doesn't mean that it's false. But the thing is when you already have something worked out and that it fits, and then you've already disproven the other camp's hypothesis that, the earth is flat, then it's over. That's when science rules, the judges in court. If you have a soccer ball on the stand and it's trying to prove if it's a sphere or if it's flat, it has pumped up air. Okay. Um, it has like a couple psi, like I don't know, 20, but okay. Let's just say a bowling ball then. All right, a bowling ball, and we're trying to figure out what the shape of the bowling ball is. Eventually, we can be confident that we know what the shape of the bowling ball is. We do the experiment. We can visually test it. We can send lasers on it. We can physically test it. You know what I mean? Measure it, and we're gonna come to the conclusion that this is a sphere. I mean, think about it. And if you couldn't see and you had to test it, physically, like map it out, you could still be confident, like, hey, this is a sphere. You can reach that certainty, is what I'm trying to say, for sure, with this type of topic when it comes to seeing something and feeling something, right? Like if you had a ball, you could feel that it was a sphere. The Earth is so big, obviously you'd need to get far away from it. That would require modern technology, but that is also not taking into account eclipses on the moon. When you see the Earth's curve, you can see that. So you didn't really necessarily need the technology to kind of see the Earth. You can kind of see the Earth's shadow. That does completely count as a visual aid. If you cast a shadow from an object, you'll be able to see the object as well. So going back to the bowling ball on the stand, eventually we can be certain that that is a ball, and there's a curve to it. It's not flat. So we should have the truth. We can literally, everyone can just stay on this one topic of what the sun is. This is enough of an experiment to feel confident what we are on, because it's the sun's far away. It's very bright. You can see it. There's no limits, and that's another thing too. We can see so far with the telescope and zoom in on things very far away, and you're not on the ocean and you can't see islands that are hundreds of miles away that you should be able to see 50-mile away like with big structures on it. We have the technology to zoom in, so why can't you see that? And it shows that you're on a curved surface. That's just another reason, because I was saying far away, so the sun is so far away, and you don't have any issues with like light refracting, which I guess you could say the light does refract a little bit with air, but for the most part, the sun gets here. I can see it in the sky. It's a circle. So in that sense, it's strong enough to not refract before it gets to me. Even like stars, which are farther away than the sun, I think even flat earthers agree that the stars are farther away. They are still able to, get through the Earth's atmosphere without refracting too much of the molecules to get to my eye, a little tiny, speck. So, I think the sun is a great way to start your research on what is the shape of the Earth. So at this point, it's conclusive. Everyone should be able to confidently say they know the shape of the Earth, and this was a little experiment or a thought experiment on how to prove something, how to disprove something, how to feel confident about it, how to think, how to not be fooled, don't be deceived. So if you're a flat earther, please, take everything you've heard, everything you've read, all the doctrine, just start completely over. That is not bad advice. Just start, if it's the truth, you're always going to find it, right? So just start over from zero, from scratch. What is the shape of the Earth? Let's not make any assumptions. Let's not believe anyone's saying. Don't even take my word for it. Don't even believe me. That's how you know I'm not trying to fool you. Go out and do your own research, and because we've done the research, and the Earth is not flat; it is curved. That is the truth, and so we're presenting evidence for you. Be open-minded. That is the only way you can protect yourself from being deceived, is always be open-minded. Be open-minded about the things that you already believe. That's how you know that, you're not deceived. I'm open-minded. If you want to say the Earth isn't curved, by all means, please tell me what I don't know. I'm open to it. And if it's the truth, I'll be able to prove it. And if it's not, like every time people talk about the flat Earth, it's not the truth, it gets disproven. I can easily see the truth from not the truth when I have it right in front of me. I can compare. I'm doing my research, so don't put any emotion in this. Just take the evidence. What does the evidence point to? Make sure you're interpreting the evidence. The the right way. And so there you have it. That is the top reason why the earth is not flat and it's round. I really tried to flesh it out with you guys. I brought up maybe a couple other points, went into a little bit of detail on things, but I really wanted you to feel confident as you're walking away right now that the earth is curved, and I am trying to get these some flat earthers, as many of them, all of them, to see that it is as well. So I was hoping this video would be very compelling for you. It was right to the point. It was I try to stay on that on one subject. We can continue this experiment. You can try to find any sort of ways to describe the sun's movement over in the sky and over the horizon, and how it would relate to the shape of the earth. So we can stay right here, and this will give us the truth. We can take images of earth. We can travel around the earth. These are all experiments we can do. This should not be something that shouldn't be discussed much further. We need to put in a reasonable amount of resources to educate people, and so we can all get on the same page and move forward, especially when it comes to logic, understanding, reasoning, knowledge, how to gain knowledge, how to make sure you're not deceived, how to think, how to answer questions. So, or come up with solutions to problems, like what is the shape of the earth. And so this is good for everyone. This raises the tide. Gets everyone would be on the same page. We would all believe what the shape of the earth is. Great. We'd all, we would all understand basic logic, and knowing the shape of the earth is very important, because that's basic logic. That's basics about shapes. And so if you can be fooled on what the shape of the earth is in 2020, doesn't that really show you? Isn't that a point right here that you can take from this video? Like, what does it show you about humans and your brain? I mean, the human brain is amazing, because it has the ability to learn and to do and not to be fooled, and to know the truth. You can be certain, right? Remember the bowling ball? So, it pains me to see so many people to be deceived, and especially when we have the ability not to be deceived. And look how people can be deceived, and and it's happened to all of us. We've all been deceived, so no one's different than anyone else. But the best thing for everyone else is for everyone else to learn from other people, get all the knowledge and the truth from other people, and combine it, right? So if we know that the earth is curved, like, give that information out, right, for someone that doesn't know. So but with the flat earthers, it's a little bit beyond that, because we have given that information. So now it's about, hey, you know what? You want to think for yourself. You want to be a critical thinker. You want to find the evidence. You want to prove it to yourself. You want to be a scientist. You want to do what you have the ability to do with your brain. That's great. That's being a human. That's what we all do, right? I'm sitting here. We're talking about knowledge and life, and humans love doing that. And I'm totally on board too. So I'm in this journey of life together with all of you. It's so great. It's awesome, right? It's such a blessing to be alive, to be able to even comprehend existence, and to be in this universe. So it's just awesome. So with that said, I hope that you guys really enjoyed this video. I hope that you can understand I'm definitely speaking from the heart. I just want everyone to be on the same page. I want the best for everyone. And I thought this was a great thought experiment to do, and it's brought me a lot of pleasure to do this research. So I hope that you enjoyed this all as much as I have. So I hope you are having a wonderful day, and I will talk to you later.